So there are two main characteristics of the perceptron algorithm. So first, it is online. So what it means in this case is that it only looks at one example at a time. So in our KNN and other algorithms, it looks at all the examples at the same time. But the perceptron algorithm only looks at an example one at a time. So that's where we see the loop here from 4 to 9, I think. So it takes a look at each example one at a time. And then also it is error driven. So it only updates the parameters when it is not doing well. So the parameters in the perceptron algorithm is the weights. So let's just put it here. So the parameters are the weights for each feature. Again, the weights determine how that specific feature influences the decision, either towards the negative activation or the positive activation. And the second parameter is the bias. So as we can see in the algorithm here, it only updates. So this one from line 6 to 9. So this condition here, it only updates the weights, the bias, or the parameters when it sees that it got the wrong prediction. So it only updates when it is not doing well. And yeah, so once we get the weights, so the weights here are from the weights we got from the previous function, this one, and also the bias. And this one is an example. So this is a test data. And then, so a test data, we don't know. So we have training data. I'm getting sidetracked here, but yeah, we have the training data, we have the input and the output for that. So we know what the actual value is. For the test data, the data also has the input and the output, but we just use the test data to see how our algorithm or model performs. And there are actual, like, real world data wherein we do not know. We only know the input, but we do not know the output. So if you're going to predict what the output would be given an input here, x sub hat or x hat, we just get the activation. So again, the activation formula, we already know this one because we got it from the previous function. And then we also have the bias here, and then we just compute the activation and then return the sign, whether positive or negative. And that's it. That's basically the basic concept of the perception algorithm. So I think I'm gonna end this video here, but I'm gonna be making another one which will I'm going to show you a simple demonstration of this algorithm written in Python. So yeah, see you there.